Okay, this lesson is on u-substitution. It's one of those topics that is really, really hard the first 3 or 4 times, and then after that, hopefully it starts to make a little more sense. But you can't give up after the first 1 or 2 examples because it's a tough concept. Okay? Now, look at number 879. You should already have this paper, hopefully. Hopefully I gave it to you. We can't integrate this because you can't split up an integral of a product and say that the integral of negative 2x times the integral of the square root of 9 minus x squared is the integral of the product. It doesn't work that way. And we can't distribute, even if we write this with an exponent of a half, you can't distribute the negative 2x because of the exponent. So we need another method. And this method is called u-substitution. Basically, you look for a function whose derivative already appears in the problem. And this is where I understand completely that you would never think to do this, but I promise after we do it a few times, you will. There's 2 functions here. I could either let u equal negative 2x, or I could let u equal this big nasty thing. Usually, you're going to let u equal the big nasty thing. And why do they use u? I have absolutely no idea. Google it. I don't know why they picked u, because all the other letters are taken, I guess. Okay, so I'm going to substitute in, and I'm going to call this nasty function right here u. What just happened? What just happened? Okay, 9 minus x squared is u. And then I'm going to take the derivative of u. Du is negative 2x dx. Look at negative 2x dx. Interesting. Now I'm going to rewrite this as the integral of u to the 1/2 because u is this thing and it's being raised to the 1/2. And then I'm going to notice that du is negative 2x dx. It's already there. Du. If that doesn't make sense to you, then rewrite the original integral exactly the way it is, replacing 9 minus x squared as u, and then solve this for dx. Divide both sides by negative 2x. So now replace dx with du over negative 2x. Notice these cancel out, and you're just left with u to the 1/2 du. This is the hard part. Now it's just what we've always done. Integrate u to the 1/2. Add 1, multiply by the reciprocal. 2/3 u to the 3/2 plus c. Problem is you can't leave u. You have to replace it with what you chose for u. 2/3 times 9 minus x squared to the 3/2 plus c. Okay, let's do another one. Don't complain, don't whine. You can do this. 880. There's 2 functions here, x and 4x squared plus 3. Well, obviously you're not going to let u be x. That would be too easy. So we're going to let u be 4x squared plus 3. Okay, I'm over here now. I don't have enough room. So u equals 4x squared plus 3. Du is 8x dx. Get it? So now, and let's do the substitution way. Dx equals du over 8x. I'm going to rewrite this integral. The integral of, the x stays the same. This thing is u. I'm going to replace dx with du over 8x. Okay, now let's simplify a little bit. This x and this x cross out. This is really 1/8, right? So I can put the 1/8 out in front, the integral of u cubed du. So now I have 1/8 times 1/4 u to the 4th, that's the antiderivative of u cubed, plus c. This gives me 1/32. Replace u with what we picked, 4x squared plus 3 to the 4th plus c. Okay, still hard, I know. Let's do another one. 881. The integral x squared over 1 plus x cubed squared dx. Again, what am I going to make u? Am I going to make it this? Am I going to make it this? Well, usually anything that's being raised to a power is going to be your u. So u equals 1 plus x cubed. So du is 3x squared dx. So dx is du over 3x squared. Let's rewrite our integral with what we know. We have the integral of x squared over u squared times dx, which is du over 3x squared. Well, here the x squareds cancel. This is really 1/3, so we pull that out in front. Integral of 1 over u squared. So 1/3 times, this is u to the negative 2, so the antiderivative is negative 1 over u plus c. Plug in u, so we have 1/3 times 1 over 1 plus x cubed plus c. You can leave it like that. That's close enough. Okay, let's try one with, well, let's look at the next one because that has an ln in it. 882. The integral of x squared plus 1 over 9x squared dx. Now this time we have a sum. So don't get all crazy trying to figure out how to separate these. So you have this plus this. Okay? So in this case, oh, this isn't even a u substitution one. In this case, you would have the integral of x squared plus 1/9 times the integral of x squared. I don't know why this is in the u substitution category. So this is just 1/3 x cubed plus 1/9 times 1/3 x cubed plus c. Simplify. That's silly. That shouldn't be in the u substitution category. 883 you can do, I think, without u substitution. You just split them into, I'll show you. Split them into different integrals. It's just sums. X squared plus 3x plus 7 over root x dx. So the integral of x squared over root x plus the integral of 3x over root x plus 7 times the integral of 1 over root x. These are all dx. So x squared times x to the negative 1/2. I just add the exponents. It's x to the 3/2. So this is the integral of x to the 3/2 dx plus 3x times x to the negative 1/2 is 3 x to the negative 1/2, 1 minus half, x to the positive 1/2, so 3 root x. And then 7 times the integral of x to the negative 1/2 dx. Okay, no substitution there. You just separate it into 3 and integrate from there. Let me find another one that has a substitution. All right, let's look at 887. That's going to require me to remember my integrals of trig functions. 887, the integral of tangent to the 4th theta secant squared theta, d theta. Well, we've done enough of these that I know that the integral of secant squared is tangent. So I should let, but the derivative of tangent is secant squared. So u is going to be my tangent because I see its derivative in the problem. So I'm going to let u equal tangent theta. Du equals secant squared theta d theta. So d theta equals du over secant squared theta. Okay, so let's rewrite the integral. Tangent to the 4th is u to the 4th. Secant squared theta, d theta is du over secant squared theta. So the secant squareds cancel, and I just need to integrate u to the 4th du, which is 1/5 u to the 5th plus c. Replace u to the 5th with what u is, so it's 1/5 tangent to the 5th theta plus c. Again, I know it's hard, but if you do enough of them, it will start to make more sense. So let's have you try 888, 890, 891, 892, 893. Are you going to know how to do that? 4x cubed, 15x to the 4th. That one seems like it might be pretty tricky. You can do 894, I think. You can definitely do 896. Did I already do 896? I don't know. But if I did, do it again. And 897. And then we'll try some more in class. 893. Yeah, that's not bad. 15x to the 4th. Right. Okay? Good luck.